Hello everyone, my name is Yunlong Xu, aka Draco. I'm an analyst of MMA 2020, and I study mathematics and computer science at Fudan University and the University of Rochester. Let's just dive into today's lecture of multilinear regression. What is it? It is just an extension of the univariate linear regression, which we have already learned. And why we need it? Because sometimes you will have more than one independent variable. And just to use your knowledge of linear algebra, we can just vectorize the variables here to a higher dimensional variables here. As you can see, the x will change to be the matrix x, which we will call it a design matrix. And for the simplicity, let's just consider the cases in two-dimensional. Here, you will see that each point will have two separate values, one in x1, one in x2. They are different separate dimensionality. And recall what you have done to have an optimal parameter theta, theta hat. Yes, you minimize the MSE for it, but there is also a MSE in a higher dimensional world, and after you minimize it, you will have optimal theta hat, which is given here as a foreign. And what we need to do is just to implement this foreign. It's very simple. You just need to use the package in the linear algebra, in the NumPy, which is called linear algebra. Use the inverse matrix of the f dot t and this x and another x dot t and y. Yeah, here it is. Yeah, you got the theta hat, and then you can compute the y hat based on the theta hat. Here is the MSE, and then you have a plane instead of a line because it's two-dimensional cases. Yeah, here is a plane. There is the result of your regression. And then let's just move into our next part, which is the polynomial regression. Why to use a polynomial regression? If you have learned some real analysis, you will know a theorem called the Weierstrass theorem, which guaranteeing that given any continuous function over a closed set, you will approximate it with a polynomial. It's very powerful, so we can just use it to regress. We need some data first, and then we want to implement the design matrix given before. Since there's nothing in the design matrix, we want to use the edge stack in the NumPy. And each time we want to add something to our design matrix, which is the degrees of x. Yeah, here it is. And oh, sorry, I forgot to do this. Yeah, here we got a design matrix when the order is 5. Then we use it to fit a polynomial regression model. We just use the function that we implemented before. The x design will be the make design matrix with the parameter x and the order. Yeah, and the theta will be the ordinary least squares, which we implemented at the very beginning, and the parameter will be the x design and y. And then we can see when the order is 0, it is just the linear regression, which we are familiar with. And if the order would be 5, as you can see, it would be red 1, and we can evaluate those models by computing the MSE. So just for simplicity, I've already wrote the arguments, and we just see the result. Yeah. Sorry, this one. Yeah. As you can see, it improves a lot when the orders become higher. So it's the benefits to use polynomial regression. I guess that's all. Thank you for listening. I'm Yunlong. Bye.